All right, this is a Traverse lift 6035. The model number on it is also useful because it talks about the statistics or the capacities of the machine. So the 60 it's a 6,000 pound rated capacity machine, and the 35 means it has 35 feet of reach. The four-wheel steering can also be used to drive the machine sideways, which is really nice because even though this is a pretty big machine, it can get into some pretty tight areas over rough terrain. Also, the whole body of the thing can twist side to side. So these things are pretty cool. It's a lot like having a crane. If we look at the accessory end of it here, right now this machine has forks on it, but that's a quick change right there. So you can go from forks to a bucket to a man basket. And being on a job site, this machine can do a lot of work on a high up building. My MIG welder is up on the roof right now, and this machine will be really easy to grab it down off the roof because the welder is too heavy to lift up by hand. This machine runs off a 220 volt, 50 amp power supply. It uses shielding gas that comes out of the nozzle, which protects the weld when it's getting welded. And it works off of, come around to the other side here. Machine has a continuous feed of wire. This wire here is 0.035 thickness, feeds out to this nozzle, and pretty much to weld with this machine, you just squeeze this and it welds. Very easy machine to use. This is a nice welder right here. If you're looking to get into welding, I'd recommend a machine like this. So let's set it up and do a little bit of welding on some steel plate. See how there's a little bit of metal builds up on the end of it? That needs to be changed. So we pull that off. So this unscrews right out of there. Feed that off. Melt it. Put a new one on. Screw it in. And this guy here, you gotta make sure that stays clean. So it's not hard to clean, but you can just, like something like that, put it on there, twist it, knock all the metal out of it. Okay, and now we are ready to go again. And there's, another thing, it's upstairs. There's nozzle dip that you can put on this, which helps it stay cleaner longer. All right, so the problem I'm going to simulate now is I'm going to turn the gas off on this thing to simulate what would happen if either the nozzle was clogged up or if you're welding in windy conditions. And what it's going to do is leave a porous weld that's kind of full of holes. So it's just all over the place. There's some crappy weld for you. All right, so you can see, all right, there's some examples of porosity, and I was just moving all over the place. This being an AC-DC model, it can do DC as well, which is a little more of a desirable process for some applications. So, I mean, the DC ones are a little bit more money to get these, but still, that's a nice cheap welder to get. So, instead of using the wire that feeds out, these use these stick electrodes. They burn shorter as you use them, so that's why you generally have big boxes of them. They clamp into this right here. And the process you use, you just kind of, a lot of things that people have trouble with these is getting started. So what you got to do is you kind of got to give it like a strike because if you go to stick it, it just gets stuck, not welding, heating the rod up, ruining the rod. It's frustrating. It's a little bit of an art to get used to the striking motion to get these rods properly started. All right, so welders are available that will plug into a normal 110 volt household outlet that people are used to seeing. Those machines do work, but if you're welding thicker material, they don't work. You'd probably be more frustrated with it. If you're welding, I mean, look at what the machine is recommended to weld, but probably when you're welding often over 3/16 thick, you want a 220 machine. And I guess I should say here, I guess I should say here that I'm probably not an expert at welding. I mean, but I have been doing it for 20 years, often on excavator things and things I do use rough after I weld it, and it's very rare that I have to revisit anything that I've either repaired or built from scratch. So I think that speaks for itself as being good at it. But whenever you post welding videos, I mean, it's like the people on YouTube, on the comment sections, like they'll say all kinds of different things about what's wrong, what's right. They're always contradicting each other. So it is a little maybe tough to get good welding information, but I guess just take all the information you can and just do what works for you. I mean, these 70-18 rods, they do work. The wind doesn't affect them. They cannot get wet. Set the amperage right in the machine. The stick welding is, I say, slower than the MIG welder. It's a lot harder to fill in gaps. It's harder to do overhead stuff. It is cheaper to do, which is nice, but I'd say MIG is the process to really use. And then there's also another welding process, TIG welding, which is more for specialty stuff, more for like aluminum, metal like that. All right, so let's fire this machine up and give it a try. So we are using 70-18 rods. We're set to DC, and I guess we'll put our amps right about there. And let's plug in our 220 plug. And that is live, so that has power to it all the time when that machine's on. So we'll just weld these two scrap plates together. Here's my ground clamp. So a lot of people who are new at this process, one thing that people often have trouble with is getting the welder started. So I'll show you what you don't do. Actually, I'm trying to see right there how it's stuck? See right there how that's stuck to the plate? That's what you don't want to do. With that heats the rod up, ruins the rod. I'm starting with a new rod right here. I mean, that rod's not ruined, but it's fine. All right, so to get started, what you just kind of going to do a flicking, striking motion, then you can go in with your weld. Just like that. My same with the MIG welder, I like doing little circles like this, making sure you burn each plate into each other. After you weld it, it's dirty, you gotta clean it off. You chip off the slag with this thing here, wire brush it with this thing. So you can see right there, that may look like a sloppy weld, but it's not. The weld is underneath the layer of slag, so we'll chip it. See that chipped away most of it? Then we'll use a wire brush. And that's your weld right there. And then if you're doing multiple passes, if it's a thick plate, you'd want to clean it off like that before doing another pass over top of that weld. When you're welding metal, you also need to be able to cut metal. There's a bunch of different ways to do it. This machine here, this is called a plasma cutter. So this plugs in with the same outlet that the welders use, 50 amp. And there are 110 versions of this machine, but wire your building for the 220 and get these. That's the way to go. So plug that guy in. This also needs to be hooked up to an air supply. That's this line here hooked up to a regular air compressor. Alright, so to fire this machine up, you turn it on. So we'll take this piece of scrap metal, we'll ground it with the ground rod, just like the welders. Then here's the nozzle. There's a few different things you can put on this depending on what you're doing, but this is just a standard cut. You don't want to touch this to your work surface. You want to keep it about 1/4 inch away. and then just kind of look at the speed that you're cutting. So I'm just going to do some freehand cuts across this scrap metal. And this is, in the lens you use, this is like the welding mask, but it's not quite as dark. The person you're buying all your equipment from will be able to sell you the proper lenses for this. So I'm going to start right on the edge here. So you can see how fast, that does a pretty nice cut. It does have the slag, but you can knock that right off with a hammer or something, kind of like the stick weld. But the beauty of this tool is you can cut anything you want. You want to write your name, you got to make a bunch of weird cuts, you can do that. Nice thing about these plasma cutters is they can do a lot of cutting without having to buy any expensive blades or gases or anything. It's just pretty much electricity and go. One consumable that does wear out on them is these little tips, but they're cheap. When I was just doing that cutting there, this tip was a little bit on the worn out side, so it wasn't cutting perfect, but it did cut fine. So when you're cutting, if you want to do a lot of the cuts I'm doing, I just do straight shots. So what you can do is use a straight piece of metal as a guide and then just trace it. So you can go right along that, clamp that down to your work surface, and you'll get a nice, perfect straight cut. Other metal cutting tools we should talk about. This guy here, this is a 4.5-inch angle grinder. This is one of the cheapest tools you can get that will cut metal pretty well. This uses these thin blades for cutting and the thicker blades for grinding. And yeah, this will cut plenty of stuff. It gets, if you're doing huge cutting projects, these, you go through these blades a little quicker than you'd want, but definitely a handy tool to have around. Two other tools I could recommend. This looks like a tool for cutting wood. This is not. This is for cutting metal. This will cut 1-inch thick plate. It does a very nice, clean job. The blades are a little expensive, but they last a long time. I just use this to cut all this 3/16 roof plate and two other saws just like this, and get very good results with it. Same thing with the metal chop saw. So this guy here, you take your workpiece, clamp it in there, clamp it down good. These tools, they do require hearing protection and eye protection. All this stuff we did today, I wear safety glasses the whole time. So, and you start it out. And look at that there. We got very clean cut with this. Now these are also available with this type of blade, and they work. They're cheaper than this one with the metal blade, but you're better off with that blade because those blades last a lot longer. They cut nicer. They cut faster. They don't shrink as you're using them. So yeah, that cutter is a couple $100 more than the regular one, but that's the one to get. So two other cutting tools I can talk about here. One, this is I guess you could say, an old-fashioned acetylene torch. It works pretty similar to the plasma cutter, where you can just kind of take this and just cut metal apart. Few advantages to this over the plasma cutter. One, this doesn't take any electricity. So if you're out in the field or something, you don't have that weird plug to plug into, you can use this. This also works a lot better if you're cutting up like in the plasma cutter, I'm cutting clean new metal that's getting installed on a new project. If you're just cutting up like scrap metal, garbage, junk cars, this does a better job than the plasma cutter. These tanks, you always seem to be getting them filled up. So bigger tanks are available, but the plasma cutter is nice because it's like unlimited cutting. This thing, you're always filling these up. All right, so to light this guy up, turn your gas tanks on, set them where they're supposed to be. You turn on your red, your acetylene first. So then, right there, that's just acetylene fire. So you can see it's dirty. We got soot coming off of it. Now you want to add in your oxygen. So I'm going to open up the oxygen valve. Let it clean up. Okay, now right there, that's the pure oxygen. That's still not set right though. You could have it set like that if you were heating up a bolt or something. I'm going to add in a little more oxygen. baby bell right there. And then to cut something, you heat up the edge of it so you get something glowing red. And then squeeze that trigger and then we'll cut. Here, we'll cut something. You do want dark lenses. These are actually torch glasses here. It's nice to have a full face thing too, but if you're good with it, you're not hitting yourself in the face with metal. And you can see that works kind of like the plasma cutter, but you definitely notice it's not as clean. Maybe the tip is a little worn out on that, but that's why these are good for cutting apart garbage, because you can cut some thick metal with this, and if it's just scrap metal or something, it does work. This is a plasma table. It uses the same plasma cutter that I was using before freehand, but instead of being freehand, it's on a computer-controlled device that can move it around extremely precisely to cut out any shape you could program into it. You have slots in there, you lay on your piece, then you use a laptop computer, you program in the cut, and this will, instead of holding the plasma tip like I was doing before freehand, this will precisely cut out any shape you may want. A lot of artists use them for cutting out decorative signs or something, or if you just need some precise pieces cut out, this will do that. These are excavator ears, which are on a quick change excavator, which can lock into the bucket to have different buckets on the machine. See how it's cut out with all these different shapes? This, you couldn't just freehand this. This needs to be cut out very accurately. So a machine like this could make these plates. You know, if I was freehanding this, like guys who have made these freehand before, they say, like, oh, you make them, but you spend a lot of time grinding them to get them to work, and then they're always kind of sloppy compared to when they're cut out on either a plasma table, or another version of this, which is even an upgrade, is a water jet. So instead of using plasma, it uses highly compressed water with a little bit of abrasive in it, and can do a very clean cut extremely accurately on a thick piece of metal like this. Some people may be questioning how strong welds are. So I post a lot of my videos on YouTube, and you know how YouTube comments can get. People always kind of asking questions on stuff. So to do a demonstration on how strong welds are today, I welded this together. This is a piece of my roofing, which is 3/16 steel plate, and this is a piece of the I-beams that I used for my rafters. I did about 10 seconds of weld on this thing right here, just to put these two plates together. Then I plasma cut these two holes in it to use this as like a hook to see how much force it would take to pull this apart. You can see there's nothing on that side. This is it, about 10 seconds of welding. Then I was going around hooking this to different weights to picking them up to demonstrate how strong it was, things I knew how much they weighed. Then I'm like, all right, well, let's go break this. Let's see what it takes to break it. This truck with nothing in it weighs 8 tons. There's about a ton in the back of it. Obviously, we're only picking up half the truck to pick up one side of it. But check this out. I'll hook this up to this crane, and you'll see how much 1 inch or 10 seconds of welding is. This is a MIG weld. That represents how strong these welds actually are. And this, again, this is only about 10 seconds of welding. This 1 inch little drop of weld was strong enough to pick up, you know, that truck, the whole thing, 8 tons. There's a ton in the back, but we probably picked up 4 tons right there, or 8,000 pounds, just off that little bit of weld. So that's what I was trying to get to in my video, where I was explaining how strong the welds are. I mean, there is hundreds of feet of weld, hours of welding, days even, holding that whole thing together, and that's how strong it is. All right, so this is Levi and Cody. Levi is a lab. He's going to be 14 in a few months. And this is Cody, another lab, who he's almost 5 months old. So he's wants to do a lot of playing. Cody kind of likes to play a little rougher than Levi may want to, but Levi, he tolerates them. You know, it's not totally finished, but right now you can see all the seams. They need to be fully welded, but there's not that many of them, since all those steel sheets came as 8-foot by 20-foot sheets. And then once that's all done, I'm going to paint it, and I may do some fascia, a few more steps to make it look more decorative. I'll be doing the block walls just like that on the top of the 2 containers where the rebar is sticking up. And Yeah, and that's pretty much it. That's the project.